Welcome, this is the video covering rigid motion. The learning target is for you to understand the characteristics of a rigid motion, and to do this, the success criteria would be explaining what a rigid motion transformation is. We start with the vocab. A rigid motion is a transformation that preserves its length and angle measurement. Preserve means keeps. Another name for rigid motion is isometric. A rigid motion maps a line to a line. That means line DE is congruent to line D prime E prime. Ray to ray, segment to segment. Because a translation, which is a slide, is a rigid motion, and a rigid motion preserves length, angle, measurement, the following statements are true for the translation shown. Line DE is congruent to D prime E prime. EF is congruent to E prime F prime, and so on, as well as the angle. Angle measurement D is congruent to angle measurement D prime. Angle measurement E is congruent to angle measurement E prime, and so on. Please understand that you can have multiple translations. When you have a multiple transformations, it is considered a composition of transformations. The composition means there's more than one transformation that occurs. Composition is a combination. So let's make sure you can understand the vocab. In this example, a composition translation occurred where there are two translations. You see the triangle in blue translates, slides to make the A prime, B prime, C prime triangle, then slides again to make the A double prime, B double prime, and C double prime triangle. You're going to explain which of these triangle lengths are the same. Try that now. We would say that the line of AB, I can show you here, it's this one. AB is congruent to A prime B prime, which is congruent to A double prime C double prime. Likewise, the CB down here is congruent to down here, which is congruent to down here. Okay? And also AC is congruent to A prime C prime, A double prime C double prime. Why is that? Because every single triangle here, the side lengths are the same value as each other, because a translation is a rigid motion transformation. It keeps the lengths throughout the transformation. The size of the length did not change. Now, here you have this image, and this goes through a translation as well. So DEFG, they slide that down here, then they slide it over to the left hand side. Explain which of these angles are the same. Try that. Here are the solutions. I would say that that the angle of D is congruent to the angle measurement of D prime, which is also congruent to the angle measurement of D double prime. That means this angle right here is congruent to this angle here, which is also congruent to this angle here. These are the three angles. Likewise, angle E is congruent to E prime and E double prime. F, 1, 2, 3, is congruent to F prime and F double prime. Likewise, same thing with G. Okay, why is that? Because every single triangle's angles are here having the same value, because during the translation is a rigid motion transformation, so it preserves the angle. There you go. Hopefully this video gives you better insight on during a translation or a composition of a translation, you can tell that the lengths and the angles remain the same.